proofs of identity laws. So, here we are going to prove the identity laws of equivalent fundamental statements. So, in our identity laws, there are 4 laws under the identity. One is of PR T is identically equals to T and P and F is identically equals to F is the first case, and in the second case, so we have to prove the identity laws as P or F is identically equals to P and P and T is identically equals to P. So, these are the 4 cases under the identity laws which we are going to prove now. So, here we are going to prove these conditions under the advanced level. Then now, so in order to prove these conditions, we have to suppose one statement, let the statement be P, and a statement may be of either true or false, but not both. So, therefore, the truth values will be of either true or false. Then now, the identity laws which we are going to prove are of true as in the case number 1, that is P or F is identically equals to P, and the second one under the case number 1 is of P and T is identically equals to P. Then now, as in the case number 2, we have to prove that P or T is identically equals to T, and as the second one, that is P and F is identically equals to F, which is the false statement. Then now, the proof starts, whereas in our proof, let us consider the case number 1. So, in our case number 1, as per the conditions which are given to us, is of first one, that is P or F is identically equals to P, and the second one as P and T is identically equals to P. Then now, whereas in the next logical step, so here we are going to prove the condition, but here we have to suppose let P be a statement but we have to prove as the number 1 as P or F is identically equals to P, and whereas the second one as P and T is identically equals to P. But in order to prove this condition, so we need truth table. So, this is the truth table of the first case, that is P or F is identically equals to P, and whereas this is the truth table of the second case, that is P and T is identically equals to the P. So, in order to prove the first condition, we have to suppose one statement, we have supposed it as P. So, here let P be the statement. Then now here we need F. So, here F is the false statement. Then now here again we need P or F. So, here P or F as in the third column. So, these are the column numbers 1, 2 and as well as the 3 columns, and whereas in the second case, so this is the first column as the second one and this as the third column. Whereas in the second case, we are going to suppose the column number 1 as the statement that is P, and the second case as second column as the true statements, and overall on the left hand side we need P and T. Then now, so we know that when we suppose a single statement, either it may be true or false. So here the truth values of the first statement, that is P, are of true or of false. Then now here second column is of false, so here both the truth values will be of F and F. Then now here third column we have to find out P or F. So here R indicates, here R is denoted by means of the symbolic notation V. Since it is R, the connective is of R of the two simple statements, that is P and as well as F. Therefore, so here P and F is the disjunction, so we have to find out the R. Whereas in case of a R, so here F and F, first statement must be of false and the second statement must be of false, then only the disjunction will be of false. Then hence, so F and F, we have to search for F and F, so P must be of the false statement. So whereas in the first case P is of true, and in the second case, so it is of false statement, whereas we need F and F as F, but it is of T and F. So in the second case it is of false and false. First statement P is of, the truth value of the first statement is of false, and the second statement is of also of false. Therefore the disjunction also will be of false. Whereas for the remaining, so you will be getting it as true. Then now, similarly, let us find out the truth table of P and T is identically equals to P. Then now, when we suppose a single statement, therefore the truth values will be of either true or false. But here in the second case, so it consists of true, therefore the two statements will be of true itself. Then now here, in order to find out P and T, so here and indicates the conjunction. So in case of a conjunction, the condition is of, if the first statement is of true and the second statement is also of true, therefore the conjunction also will be of true. That is, the conjunction of P and as well as T also will be of true. Then now, so we have to search, the first statement must be of true. So in case of a P, the truth value is of true, and in the second case it is also of true. So true and true, and the conjunction also will be of true. Whereas in the second case the first statement P must be of true, but here the statement's truth value is of false. So here therefore here we will be getting it as false. Then now, so here in order to prove P or F is identically equals to P, we have to see P or F is under the column number 3 and P is under the column number 1. So we have to observe 1 and the third columns. So here the truth values of the first column and as well as the third column are of T and F and T and F. Therefore the truth values are same. Hence the P and F, so P or F is identically equals to P in the first case. So in the second case, so P and T is in the under the column number 3 and P is under the column number 1. We have to observe the truth values of P and as well as P and T under the columns 1 and as well as 3. So the truth values of these two are of similar, because here the truth values of P are of T and F and the truth values of P and T are also of T and F. Therefore the truth values are similar for column number 1 and column number 3. So hence P and T is identically equals to P. So here we can write it as, so here since truth values of columns 1 and as well as 3 are similar, or in other words same, in both the cases, that is case number 1 and as well as case number 2. So here hence in the first case we can write it as, so P or F is identically equals to P, and similarly here P and T is identically equals to P. So hence it is proved. Then now in the similar manner